All right. I have the pleasure of introducing our next speaker. Our next speaker is a starter of many things. He organizes the Ann Arbor New Tech Meetup. He started the Coffee House Coders Meetup in Ann Arbor. He was the technical co-founder of Olark, a live chat platform enabling businesses to connect with their customers. He is currently a software architect at Duo Security. Please join me in welcoming Zach Steindler to the stage.
How are y'all doing? I love this conference. The field of operations is changing so quickly, and not to pick on other programmer friends, but JavaScript frameworks, they're also changing quickly. But I feel like our understanding of what operations is and the sophistication that we take as we approach it is improving rapidly year over year. And so I love coming to this conference and hearing what other people are doing, being able to share what we do and sort of learn together. Face-forward presentations, they're all right. The open spaces are great. Definitely stick around for this afternoon. So my journey to operations, I started programming professionally about 10 years ago. Very soon after I wrote my first program, my manager was like, great, put it on a server and make sure it never goes down. So that was okay, but a little unsophisticated. Around that same time, we came up with this idea with DevOps. And not only did it give us a great name for tech conferences, but it also sort of introduced this idea of automation and the power of automation. I was really sick of spending Friday nights SSHing into like 20 different servers to do releases. And it turns out that the tenet of DevOps is to use automation to make this much easier. Then 2 years ago, it kind of got upended again. SRE, Site Reliability Engineering, isn't like a replacement for DevOps. It's more of a yes and it added in these additional categories of things like capacity planning, things like alerting, and again, not just like doing them at all, but how to really systematically approach them as an engineer. It happened that around the time that SRE was being popularized, when the O'Reilly book came out and lots of people were starting to write articles online, I also switched jobs, and there was like another area that was getting added. I started at Duo Security, and the operations team there has a lot of additional responsibilities besides what you'd consider traditional operations. We're responsible for onboarding new employees. We're responsible for assessing and then prioritizing fixes for different security threats. And we're responsible for hardening the infrastructure. And so really about 2 years ago, I started making this transition from just an operations person to an operations person who also has to know about security. And that was a little scary. But before I get too far ahead of myself, this is Protecting Duo without Duo. I'm Zach. You're at DevOpsDays Detroit. When the idea for this talk is that I wanted to talk about the ways that we secure Duo's infrastructure without sort of like handing you a manual for how to hack Duo. My manager said I couldn't do that. But instead sort of talking about the way we think about security so that you can take those ways that we think about security and apply them to your company. If you have higher security requirements, if you have lower security requirements, just as a way to sort of help bridge this gap between operations and security, help those two departments be more friends and have more collaborative relationships. A funny thing happened though between when I pitched this talk and when it was accepted. Oh man, where's the logo? We were bought by Cisco. The logo is supposed to be in the corner there. So even though the title of the talk is Protecting Duo without Duo, it was like protecting the Duo business unit within the security business group. It didn't all fit on a slide. But we are now part of Cisco, and we're excited to see what that future brings working together. Okay, so how can security and operations be friends? Usually the goal of operations, or at least the goal that I've been working towards for the past 2 years at Duo, is how do we decrease toil? How do we decrease the amount of manual work that we have to do in order to do our jobs? This lets us focus on more interesting tasks. This lets us tackle additional challenges if we're not always spending our whole day SSHing to servers and doing manual operating system upgrades, that sort of thing. At the same time, though, at least at Duo Security, the operations team has this other objective, which is increased security. So I wanted to try to find some projects that we've done at Duo in the past 2 years that both helped us decrease toil, sort of satisfying that operational aspect, and that also helped us increase security and sort of walk through what that looked like and how we were thinking about tackling those projects. So the 3 projects we're going to talk about is onboarding, offboarding employees, prioritizing threats sort of on the software side, and then hardening your infrastructure over time to make it more difficult for attackers to get a foothold. Okay, onboarding, offboarding. Another awesome advance in the past 10 years or so is this idea of software as a service. I'm really glad that I don't have to maintain an email server, a calendar server, all these different systems as the operations team. The flip side of that, though, is that if you don't do anything by default, people just sort of like go into each of these systems and they create their own username and password. And then when an employee leaves at Friday at 4 p.m., you get this email. It's like, urgent, read immediately, must do before end of business day. Go through the 10 to 100 software as a service systems that you use and make sure this employee's been offboarded. That sounds like the opposite of decreasing toil. That's like the last thing that I want to do. So instead of letting users create these individual accounts in each of these, perhaps you've heard this terminology before, you want to have some sort of system that acts as an identity provider. And so instead of people logging into their email with a specific username and password, they maybe go through like some other login flow, and then it redirects them to their email. The main benefit here is you have this one sort of centralized place in which you can enable, disable users. Then you have to spend your Friday night making sure that you caught all 100 different places where someone might have a user account. So easy to say, hard to do. What does that look like in practice? Well, I hope you like options because there's a lot of them. Not all these options are sort of created equal. OAuth, they're like, we're not like we're not an implementation. We're sort of like a specification or just like just an idea. The general idea is that you have a system that's your identity provider and a system that's your service provider, and you have this token that people can't modify that sort of gets passed back and forth between them. Most often, this is implemented when people are using G Suite, Google's offering for businesses, but more and more software as a service companies that offer hosted software platforms or places to host your source code, things like GitLab, things like Bitbucket, things like GitHub, also offer the ability to do OAuth integrations. LDAP isn't really a specification, it's just more of a protocol for 2 systems to talk to each other. A lot of times when we work with universities, or if a shop is on the Microsoft stack, if you are running your own Active Directory, or if you're using Azure AD, that often offers a LDAP integration. And then the bottom 2 are more for the DIY route. If you control the source code of the application and you're running it on your own infrastructure, there's this idea of a authentication proxy. So this is something that sits in front of your application. It does the check with the identity provider to see if this person still works at your company or not, and then it sets a header that it passes to the application. The application just trusts that header. So the advantage here is it's sort of very easy to implement. You don't have to necessarily stand up a complex system with a third party. The disadvantage, of course, is you really need to make sure that header can only be set by that intermediary, and that people can't just go to the application and set their own header. And then SAML is, depending on your perspective, either the best thing since sliced bread or just a terrible nightmare of sadness. It's like the most generic approach you could possibly take. It has these separate concepts of a service provider, an identity provider, and this way that like XML documents are transferred back and forth between them to perform these security assertions. I think actually SAML stands for the Security Assertion Markup Language, built on top of XML. It's a little terrifying. There are a lot of commercial options for SAML. And so unless you really want to geek out about security stuff, I would highly recommend looking at what sort of commercial options might be available there. So at Duo, we had all these different systems that employees had to log into. We didn't want to manage individual user accounts. And so in particular, one example of how we addressed this was with setting up a SSH Certificate Authority. Stop me if you've never seen this before, but if you have like, some small number of developers, in this example 3, and then you have a lot of application servers, in this example 20, you have sort of this like n times m problem where you have to take all these developers' public keys and distribute them across all of the servers. It's not the end of the world. You can use automation frameworks to maybe speed up this process. But if you need to have security assertions like by the time someone is no longer an employee, within 1 hour they can no longer access infrastructure, you're like, okay, well, we ran it against the application servers. What about all the data stores? Oh, did we like miss that one web server? It's a little terrifying to have this information spread completely across your entire infrastructure. And of course, as you scale up, either your organization or your infrastructure, it only gets worse and worse. So the alternative that I learned about at Duo is to have something called a certificate authority. So instead of having each individual employee's public key distributed across all the servers, you sort of designate one server or a group of servers as the certificate authority. It generates a public-private key pair, and you only have to distribute its public key across all of the infrastructure. Then later, when a developer comes in for the day, they can run a script to check in with that certificate authority. They will send it its public key and some sort of assertion that they are who they say they are. So at Duo, we have a little Python script, and they pass a OAuth token that they got by signing into Google in their web browser. The certificate authority will take that and check with the identity provider, in this case, Google's G Suite. If that person is an employee, they will sign the developer's public key with the certificate authority's private key and return it to the developer, usually with some sort of short expiry. Could be an hour, could be a week, sort of whatever security requirements that you have. And then when that developer is connecting to individual application servers, instead of checking the public key of the developer, they're actually just checking the signature from the certificate authority, and that's, that person sort of like checked in for the day and is still an employee. And so I really like this example as a way to sort of like decrease toil, because we're no longer having to go through all of our individual servers. But at the same time, we've increased the security, and we now have this assertion that within some short period of time, people who no longer work at Duo can no longer access the production service. As I mentioned, at Duo, we chose to build it ourselves. I really don't like the build-it-yourself mentality. Unfortunately, when we decided that we wanted to go ahead and do this project, there weren't any open source options, but that's changed. Netflix Bless has been released. It's the certificate authority system that they use internally. And so if you don't want to build it yourself, and I highly recommend not building things yourself, definitely check that out as a possible option for your organization. Okay, next up, prioritizing threats. I really knew very little about computer security when I was starting at Duo, and luckily we have an entire security team that makes sure that everyone across the organization, not just the operation team, not just the engineering team, but really everyone sort of has a fundamental understanding of security. Before that, I would read Ars Technica, or you would read some blog post and it'd be like, oh, the sky's falling, there's some new vulnerability, the entire internet is broken. Occasionally that's true, but very often it's not true. And it's really unfortunate that the security industry kind of has these like scare tactics to get you to buy more products, or drop whatever important project you were working on and like patch all the servers today. But unless you're super familiar with the security or the details around these like exploits, how are you supposed to assess if you need to be like in Chicken Little mode, or if you need to be in sort of like cool-headed Planet Money economist mode? It wasn't really clear to me how to sort of like make those decisions. And so it turns out that this is something that security researchers have thought quite a bit about. There's lots of different frameworks available. Microsoft first heavily publicized DREAD, D-R-E-A-D, like that's supposed to make you feel better about security vulnerabilities, in the early 2000s. And it was a way of sort of going through and assessing like how risky different exploits were. As security researchers thought about it more, they're like, well, this part works really well, this part doesn't work so well. And so actually, the US government, specifically NIST, the National Institute for Science and Technology, recently published the Common Vulnerability Scoring System, version 2. Like any good government document, it's about 100 pages long. I couldn't fit 100 pages onto the slide. And so instead of trying to take all the different 20 categories they list and going through them, I tried to sort of summarize them quickly as to something that you could easily use when assessing a new potential vulnerability. So there's 3 general areas to think about. The first is how complex is the attack? And so you could think all right, this is something that someone published a research paper, but it's never happened in the wild. That would, of course, be low. Or maybe there's already some sort of exploit kit that's making its way around the internet. That would be high. Maybe this requires a user to click a button and then within 13 seconds enter their password and then do some other action. Okay, that's that's sort of that's high complexity of the attack, but of course the threat of the complexity would be low. Or it's something where you just have to send network traffic to a computer and then you have a root shell on it. So that's that's sort of a high complexity threat. The next category is impact. So when you're thinking about what's the end result if the attack is successfully pulled off? Have they denied service to some not critical service? Did they cause your email server to reboot? That's low impact. Or worse, customer personally identifiable information exposed. That would be high impact. And then the third sort of category is the scale of the exploit. Are there a few customers that you need to work with to have them update their software or update their configuration to prevent this attack? Or does it really impact your entire business? And so it doesn't really matter what values or what scale you sort of use for this. Some people are oh yeah, we only size sprint stories and t-shirt sizes. I don't know how to multiply t-shirt sizes together, so maybe stick with numbers. At Duo, we use a scale 1 to 5. Some people 1 to 10. But you sort of give each of these categories a ranking on that numeric scale, and then you multiply it together. It's really quite simple when you step away from it. From there, we usually bucket things into 3 sort of classes of vulnerabilities. High, those require immediate remediation. Medium, something where we sort of file a ticket and we work on it in sort of the next week or two. And then low, where we're well, there's an issue in Java on a server that's firewalled off from the internet. We'll update Java next time we do our regular operating system updates. And of course, you're all regularly updating your operating system, right? Hopefully. So if it falls into that high or medium category, we take an additional step where we come up with a remediation plan. The remediation plan isn't drop everything and fix this, unless it really is that sort of highest category, but it just gives us an idea of how much effort is it going to be to fix this? Is it going to take someone an afternoon? Is it going to take the whole company a week? And then from there we can sort of derive our priority. Depending on how urgent the problem is and how much work it'll be to fix, we can make sure that we're spending our time sort of tackling the most important issues and not getting lost in the sort of infinite laundry list of minor security vulnerabilities. In practice at Duo, there's sort of 2 places that we interact with the system. We subscribe to CVEs. We subscribe to mailing lists for any sort of third-party software system that we're using. And then we also have issues that are reported either externally or internally, and that all goes into a spreadsheet. And then the operations team at Duo has a sub-team that is sort of actively managing our infrastructure. They're the ones who are making decisions about when to do deploys. There's the first layer of on-call, and then they have a variety of other responsibilities, including checking the spreadsheet once a week, going through scoring, and then if anything crosses this medium or high threshold, coming up with a remediation plan or enacting that remediation plan. And the worst case scenario, sort of pulling the cord and being stop, we need to make sure that we address this before we release new software. And then for things that fall into that medium bucket that are difficult to remediate, or the low bucket, we put it onto a backlog. And then next time that we do our planning, either monthly or quarterly or yearly, we just sort of look through that prioritized list, and we can figure out where we can spend our time to improve our security profile, again, without sort of getting lost in the weeds of all of these minor security vulnerabilities that get announced week to week. Cool. The last category that I wanted to talk with you all about is hardening infrastructure. So a lot of the prioritizing of security threats falls more on the software side, but the operations team, of course, is responsible for standing up and maintaining our infrastructure. And there's a variety of security improvements, let's say, that we know that we'd like to make. Just like before, we apply the same sort of prioritization scheme. We look at the impact of any of those ideas, how much effort it would be, and then we use that to sort of decide what we're doing in a given month or a given year. Another source of these infrastructure hardening tasks are compliance. Perhaps you've had to work with PCI or SOC or other compliance regimes. They're not as bad as you might think, or at least they're not as bad as you might think when you have an awesome compliance team to work with. And we'll talk in a second about some strategies for working with compliance teams. And then I wanted to touch a little bit on frameworks and how to sort of make it easy for everyone across your organization to work together to make it easy to secure your infrastructure. Okay, compliance. I was really scared the first time that I had to work with our compliance team. You sort of hear these like nightmare scenarios where someone's like, stop, you can't do anything until you figure out how to make sure that you've like ROT 13 triple DES encoded all communication between servers. And you're like, I don't even know what that means. What are you talking about? Instead, the way that Duo tries to approach compliance is to think about what these specific controls and specific requirements are trying to ensure, and then figure out some way to meet those security properties, even if it's not precisely what was written in the documented standard. And in fact, I was surprised to learn that these documented compliance standards change over time. The people who are writing them are sort of doing the best they can, but they always make mistakes or they have an incomplete understanding. SOC is actually a compliance regime that comes from the accounting space, and it has all of these mandates about how infrastructure should be provisioned. And of course, they work with people to try to make sure it makes sense, but it does evolve over time. Is it okay if I call on people? I'm going to call on people. Let's say that we have an application server and we have a database server, and we want to secure communication between these two systems. What are some ways that we can secure communication between these two systems? SSH, yeah. So using some sort of, making sure that that communication between the application server and the database is encrypted. Yeah, for sure. Are there other ways that we can secure communication? Oh, I heard certificates. That would be spiffy. Maybe people were paying attention during the first talk. You can use certificates to prove the identity, similar to SSH. If you have a public key, a private key, you can sort of use that to make sure that only certain systems are allowed to communicate between each other. Other ideas? They can be wacky, it's okay. Put it all on localhost. You could. It wouldn't scale very well, but it's an option. You could do port knocking. Please don't do port knocking. There must be at least one other way, though. How do we secure communications between application servers and databases? Firewalls, passwords, yes. Yeah, this is great, right? So in a couple of minutes, we came up with 5 different ways that we could secure these two systems. That becomes really important when you're either working with your internal compliance team or when you're talking to the auditors. First of all, you never want to have one mechanism that's ensuring your security, because inevitably you'll mess it up, or at least if you're me, inevitably you'll mess it up. And so if the difference between you misconfigured the firewall and your database was exposed to the entire public internet until you realized your mistake, that's really bad. Or if it's you misconfigured your database firewalls and only people that had the password could talk to it, that's a world of difference, right? That's oh crap, we have to spend a couple of weeks investigating the security incident versus, oh, it's okay, don't worry about it. So we want to make sure that whenever we have some sort of desired security property, it's being enforced at least 2 ways. And then depending on the importance of that security property, maybe more than 2 ways. The other reason it's really helpful to have that list is because when you're talking with the compliance auditors, you might not be able to sort of like meet the letter of the law. One that we've run into before is malware detection. A lot of computer systems do malware detection by executing code in a sandbox, and then if it does malicious things, it blocks it. The problem is that the sandbox doesn't always work. Famously, Windows Defender in Windows 10 wasn't sandboxing JavaScript, and so if you sent JavaScript over the network to computers, they would just execute it. That's a problem. So you want to make sure that when you're implementing your compliance controls, that it's not actually actively weakening your security posture. And if you have multiple ways that you might address a potential security threat, when the auditors are like, you have to have malware, you can be like scanning and detection. You can be like, well, it has these problems for these reasons. Here are these other things that we do to sort of mitigate that threat. Maybe we're scanning all network traffic that's coming into our network. Or maybe there's some system which guarantees that only certain programs can execute on the system and not other programs. Binaries have to be signed or something like that. So it's very useful to have that arsenal when you're talking to compliance officers. Last and definitely not least, I mean, I'm preaching to the choir here, but automation is phenomenal. The way that we set up our infrastructure at Duo is with Ansible. And I like Ansible. It has a lot of benefits. I don't think it is the end-all be-all. It certainly has its flaws. So don't walk away from this talk and be like, we got to use Ansible. But do have some sort of automation framework you're using to interact with your infrastructure. My favorite recent example is we realized 2 months ago that some of our data stores had maintenance windows that were configured during the workday with our cloud hosting provider. Whoops, that was not the intended configuration. And so we have a lot of data stores. I'm going to guess somewhere in the neighborhood of 100, over 100 at least. If we had to individually go to each of those and sort of audit what it was currently set to, change the value, and then verify that the change took place, we're talking like a week, like maybe a person spending a week doing this task. Instead, because we're provisioning all this with automation, we're able to change the defaults in our automation, and then we're able to write a little one-off Ansible script that just iterated through all of our data stores and made sure their maintenance windows were updated. And this took one person an afternoon. And so, if you like doing other things besides, a lot of menial work, it's essential to have some form of automation. In addition to that, we've written Ansible modules that help people make secure infrastructure. The operations team at Duo is like 10 or 20 people, and the engineering team is much larger than that. And so the people who are implementing these systems, they want to make secure infrastructure, but they also have all these requirements they're receiving from customers. They're collaborating with our design team, and they're trying to get product out to our customers. So instead of giving endless lectures about how it's important that very few instances have public IP addresses and that firewall rules are tightly scoped, we added automation that sort of ensures these properties, so that when people are setting up load balancers, when they're standing up databases, that things are sort of like secure by default. There are ways where you can go in and specify additional rules in our automation, and then it shows up in our code review, and we can use that as a jumping off point to be like, well, why do these application servers need public IP addresses? Do we think about doing it this other way? How can we work together to sort of create more secure infrastructure? And then sort of completely unexpected, once we had this automation framework, we were able to take our code that stood up our production environment, and we were able to point it at a separate AWS account, and then create a prod-like deployment that was very similar, except it didn't have any customer data in it. And this was an incredible boon, because we could start having our engineers who weren't operations people experiment with improving infrastructure, experiment with standing up new infrastructure. They could post their own Ansible diffs, and then the operations team could review them. So we sort of took the operations team from being a blocker to this process of deploying a new system at Duo, and we sort of like minimized the amount of time that they actually have to spend to doing the code review, as opposed to like doing the whole project by themselves. So that's another reason to consider automation if you weren't already convinced. Okay, so to sum up, when you go back to your organizations after this conference, think about projects where you can sort of double dip. We're always looking for ways to decrease toil, increase automation, sure, but also are there ways that we can change our systems so that at the same time we're becoming more secure and starting to work down that security backlog, and not just addressing it randomly, but really doing sort of like the highest impact projects to raise your security profile over time. Speaking of which, I think I'm out of time, so thank you.